my name's Brian Blair. I'm an instrument scientist in the Laser Remote Sensing Laboratory at Goddard. LVIS is it's a high-altitude laser swath mapping system. So it's designed to measure the surface of the Earth. So whether it's the topography, the elevations of the surface, or the structure of vegetation, or the changes that are happening to the surface, whether they're subtle changes, for example, volcanic sources, underground magma chambers, or very dynamic surfaces like glaciers, for example. So it's a unique capability because we can map incredibly large areas from a high-altitude aircraft. So we can map, actually, we're getting to the point where you can map an entire nation with a laser system, so it's quite good. For IceBridge, there was a number of goals of IceBridge, namely to keep track of what changes were happening to the ice sheets in between the two ICESat missions, ICESat-1 and ICESat-2, to actually get out there on a yearly basis and monitor the changes. And then there was a more long-term goal, which would be to try to help tie those two satellite missions together. In one aspect, you'd be looking at individual glaciers, and the other one, you'd actually be trying to lay out large grid patterns all over Greenland. So you could look at the changes over 10 or 20 years, and it would contribute to that. So what LVIS brings uniquely is the ability to cover enormous areas very cost effectively. What we've been doing so far with IceBridge is going back at a stable time in the ice sheets. In the spring, for example, in Greenland, we go in the March, April, May time period because the drastic changes, the seasonal melt, the accumulation from the winter have sort of stabilized. So we can go back once a year and look at those long-term trends in those ice sheets. So what we're doing this fall, we're going to see a 6-month change. And that 6-month change is more related to those seasonal effects, the summer melt that's been occurring. So we can go in there and look at glaciers and some of the interior of the ice sheets and see how much melt has occurred. And with LVIS and all the spring mapping that we did, we'll be able to look at that change over large areas. One of the really unique technologies about LVIS is there's some optical limitations to telescopes. So a telescope can only be so large, collect so much light, and see so big of an angular field of view. So with LVIS, we actually have a very unique lightweight scanning system that actually scans the field of view of the telescope constantly as we're flying along. So it's actually sweeping back and forth about 10 or 20 times a second. And then within that field of view, we're scanning our laser very, very quickly to make that full image. So it's a unique technology that allows us to have a large telescope, which you need to be able to collect all the photons and the reflected light from the surface efficiently. So it's a large collecting area with a large field of view. NASA Wallops Flight Facility has recently acquired a C-130 aircraft. It's a large turboprop aircraft. It can fly at 30,000 feet, has pretty good endurance. So that's what we're going to put LVIS on, the two LVISs on this year. There's a lot of capacity of this aircraft. You could actually fly quite a number of instruments. And so we'll be the first to use it for NASA.